Okay, so write down the first problem. Write down first problem. Okay, write down first problem from the screen. The wall of an industrial furnace. First problem on the Fourier's law of heat conduction. The wall of an industrial furnace is constructed from the wall of an industrial furnace is constructed from 0.15 meter thick brick is constructed from 0.15 meter thick brick thick brick thick brick thick brick. Anyone reply me? Screen is visible. Hello, anyone?
Yes, yes, sir.
Okay,
Yes, sir.
okay, so write down the problem. 0.15 meter thick brick having thermal conductivity of having thermal conductivity of 1.7 watt per meter Kelvin watt per meter Kelvin watt per meter Kelvin full stop watt per meter Kelvin full stop. The temperature of inner surface is 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 1400 Kelvin. Temperature of inner surface is 1400 Kelvin and outer is and outer is 1150 Kelvin 1150 Kelvin 1150 Kelvin Kelvin full stop. What is the rate of heat loss? What is the rate of heat loss? Rate of heat loss through rate of heat loss through 0.5 meter by 0.5 meter by 0.5 meter by 1.2 meter 1.2 meter on a side on a side on a side on a side question mark. Okay, so this is the problem which is related to the Fourier's law of heat conduction. This is the problem which is related to the Fourier's law of heat conduction. So we know that what is the Fourier's law of heat conduction? Rate of heat flow means Q is directly proportional to area. कुठला एरिया असणार आहे? एरिया which is normal to the direction of heat flow and change in temperature with respect to distance. So Q is directly proportional to area and dt by dx. So area means what? Surface area which is normal to the direction of heat flow. dt is nothing but temperature difference and dx is nothing but thickness of that particular object. Thickness of that particular object. So what is the equation? Q is equal to k into a into dt by dx. So by using that equation we have to find out the value of rate of heat loss. Okay, rate of heat transfer or rate of heat loss is the same for this problem. So we have to find out the value of Q. So first of all we have to write down the given. So what is to be given? The wall of an industrial furnace is constructed from 0.15 meter thick brick having thermal conductivity of 1.7 watt per meter Kelvin. So that thickness is nothing but it is denoted by dx, or sometimes it is also denoted by L. So we have to write down dx, that is thickness of that particular brick is given. So that is dx is equal to, another notation for that dx is nothing but thickness, and it is also denoted by L. So write down dx or L is equal to 0.15 meter. 0.15 meter. Then what is to be given? Thermal conductivity of that wall is given. Thermal conductivity is given, means K is given. So write down K is equal to 1.7 watt per meter Kelvin. 1.7 watt per meter Kelvin. Okay. Then what is given? The temperature of inner surface is 1400 Kelvin. Okay. So inside temperature is given. Inside temperature is higher. Inside the furnace the temperature is higher. One wall is given. For that particular wall, heat transfer takes place from the inside wall to the outside wall. So inside wall temperature is given 1400 Kelvin, and outer wall is temperature is given 1150 Kelvin. Okay, so write down T1, which is the temperature at the inside. So T1 is equal to 1400 Kelvin, 144 1400 Kelvin, and outer is given, means T2 is given. So T2 is equal to 1150 Kelvin. T2 is equal to 1150 Kelvin. Then what is the rate of heat loss? Means we have to find out the Q. So Q is equal to question mark. Write down Q is equal to question mark. And loss, heat loss through 0.5 meter by 1.2 meter on a side. So whatever the inside surface, from that heat loss is takes place from the inside surface to the outside surface. So we have to find out the area which is normal to the heat direction flow. So we have to find out the surface area of that particular wall. And how to find out that surface area? That is nothing but 0.5 into 1.2, because the dimensions of that particular wall is given. Through that heat transfer is takes place. So area is equal to 0.5 into 1.2. Take the product of these two, then we get the area is equal to zero point 0.6 meter square. 0.6 meter square. Now use the equation Q is equal to K into A dt by dx and find out the value of Q, and put that answer in the chat box. Find out the value of Q. So Q is equal to K. K is given 1.7 watt per meter into Kelvin into area. Area we have calculated, that is 0.6 meter square. Then dt is nothing but temperature difference. And suppose, what is the standard equation of Fourier's law of heat conduction? That is Q is equal to minus K into A into dt by dx. When we have taken the negative sign, at that time dt is equal to what? T2 minus T1. But if we have not taking the negative sign in the equation, then dt is nothing but T1 minus T2. Okay, so dt is equal to T1 minus T2. So instead of dt, we have to put T1 minus T2 divided by thickness of that particular brick. That is, what is the notation for that? Dx or L. So divided by that dx is nothing but 0.15. So put that values into the equation and find out the value of the rate of heat loss. Brick wall. Okay. Dhanashri Sonam have calculated the answer. Then Rhythm Parmath. What about the others? Okay. Yeah, sir have calculated the answer. Write down the unit also. What is the unit of that? Q. Rate of heat transfer. What is the unit of rate of heat transfer? That is joule per second means watt. So answer should be in the watt. What about what about others? Put their answer in the chat box. Okay. So what is the equation? Q is equal to K into A into dt by dx. Okay. So how to write this equation? Q is equal to K into A into dt by dx is nothing but T1 minus T2 divided by L. Okay. So from that Q is equal to what is the value of K? K is given 1.7 into area 0.6 into T1. What is the value of T1? That is 1400 minus T2 is nothing but 1150 divided by what is the thickness? Thickness is given 0.15. Okay. So from this calculation, Q is equal to what? What is the answer of Q? 1700 watt. Okay. So those who are remaining, write down the equation, write down the answer. Okay, Q is equal to K into A into dt by dx. जर तुम्ही इथं नेगेटिव्ह साइन घेतला मायनस के इंटू ए इंटू dt by dx, at that time dt is nothing but t2 minus t1. And if suppose we have taken the positive sign, so now I have taken the positive sign. So dt is nothing but t1 minus t2. So thermal conductivity is given 1.7, area we have calculated 0.6, T1 is given 1400, T2 is 1150, and thickness is 0.15. So from that we get the value of heat loss, that is 1700 watt. Okay, reply me. All of you get the answer. Okay, so write down the second problem. Okay, this is the answer for the first problem. Okay, write down. Write down second problem. A plane wall is A plane wall is 75 mm thick. A plane wall is a plane wall is 75 mm thick, 75 mm thick, and its wall area is and its wall area is 2.5 meter square, 2.5 meter square, full stop. If its conductivity is if its conductivity is if its conductivity is 9 watt per meter degree Celsius, if its conductivity is 9 watt per meter degree Celsius, watt per meter degree Celsius, and surface temperature is steady at surface temperature is surface temperature is steady at steady at steady at 150 degree Celsius, 150 degree Celsius, and 45 degree Celsius, 45 degree Celsius, 45 degree Celsius. Determine the heat flow. Determine determine the heat flow across the plane wall. Determine the heat flow across the plane wall. Same problem is there. Now we have to find out the answer for this. Answer for this. First of all, you have to write down the given. What is to be given? Write down by your own and put that answer in the chat box. Okay. In first problem, they are given in the thermal conductivity watt per meter Kelvin, but in this case, they have given the thermal conductivity in watt per meter degree Celsius. In the first problem, they have given the values of the temperature in the Kelvin. Now they have given the values of the temperature in the degree Celsius. So according to that, we have to find out the value of Q. Okay, first of all, we have to convert the values of mm into meter. So thickness is given 75 mm. So we have to convert that thickness into meter. So 75 mm is nothing but 0.075 meter. So area is given in the meter square. So 2.5 meter square. Then thermal conductivity is given 9 watt per meter degree Celsius. And then inside and outside temperature is given 150 degrees Celsius and 45 degrees Celsius, that is T1 and T2 is given, and determine the heat flow across the plane wall. Okay, so write down the given conditions. Anyone get the answer? Okay, Dhanashri Sonone. Okay, Rhythm Parmar. What about others? Only 4-5 students are solving the problems. What about the others? Please solve the problems by your own. Without the solving the problems, you can't understood the concept of that. So this is the simple problems related to the heat transfer. But there are, after this, there are so many equations are there, and on that equation so many calculations are there. So there is a need to be calculate the different answers, so that we have to calculate by your own. Okay, so for this case also same equation is there. Okay, so we know that equation Q is equal to K into A into dt by dx, or thickness. Okay, so Q is equal to, how to write that equation, K into A into dt is nothing but T1 minus T2, and thickness we have considered as a L. Okay, so put that values into the equation. So Q is equal to, what is the value of K? K is given 9, area is given 2.5, area is given 2.5, then T1 minus T2. Okay, T1 minus T2, that is nothing but 150 minus 45 divided by thickness. Thickness is given in the meter 0.075. So from that we get the value of Q. So Q is equal to what? Q is equal to 31500 watt. Okay, so write down. Simple problem is there. Only in this time they have changed the unit, but the, what is the unit of thermal conductivity? Watt per meter degree Celsius is given. So we have to take the temperatures in the degree Celsius. So T1 minus T2, that values are also given in the degree Celsius. We have taken the that values in the degree Celsius, that is 150 minus 45, and thickness is given 75 mm. So we have converted into meter, that is 0.075. So from that we get the value of Q is equal to 31500 watt. Okay, so this is about the problem number 2. Write down next problem. Write down third problem. Write down third problem. A heat rate of a heat rate of 5 kilowatt a heat rate of 5 kilowatt is conducted through a section of an insulating material. A heat rate of 5 kilowatt 5 kilowatt is conducted through a section of an insulating material, a section of an insulating material of cross section area, insulating material of cross section area 20 meter square, cross section area 20 meter square, 20 meter square, and thickness 2.5 centimeter, 2.5 centimeter, 2.5 centimeter, full stop. If the inner surface temperature is, if the inner surface temperature is 415 degrees Celsius, if the inner surface temperature is 415 degrees Celsius, 415 degrees Celsius, and thermal conductivity of material, and thermal conductivity of material is, and thermal conductivity of material is zero point 0.2 watt per meter Kelvin, zero point 0.2 watt per meter Kelvin, watt per meter Kelvin, watt per meter Kelvin, comma, what is the outer surface temperature? What is the outer surface temperature? What is the outer surface temperature? Okay, by using the same equation we have to find out the value of outer surface temperature. So we have to find out the value of T2. Okay, so write down the given, and then we have to use the equation of Fourier's law of heat conduction and put that values into that equation and find out the value of T2. Okay, find out the value of T2. Okay, find out the value of T2. Put that answer in the chat box. Okay, Arti have found the answer 719.25 Kelvin. Okay, what about others? Find out the value of T2. What about others? Put their answer in the chat box. Okay, simple problem is there. Only we have to find out the T2. Okay, so first of all you have to write down the given thing. Heat rate is given 5 kilowatt, means Q is given. Q is equal to, okay, Arti and Dhanashree, check your answers. Arti get the answer 719.25 Kelvin and Dhanashree got the answer 656.75 Kelvin. Okay, check which answer is correct. Okay, what about the others? So put that, write down the given things. Q is given 5 kilowatt, then cross section area is given 20 meter square, then thickness is given 2.5 centimeter. We have to convert into meter. So 0.025 meter. Then if the inner surface temperature is 415 degrees Celsius, that is T1 is given. Then thermal conductivity is given, K is equal to 0.2 watt per meter Kelvin. Watt per meter Kelvin. So what is the outer surface temperature? We have to find out the value of T2. So we have to use the same equation. Okay. By using that, so what is the equation? We know that equation Q is equal to, okay, so Q is equal to K into A into dt by dx. Okay, so what is the standard equation from this? So Q is equal to K into A into dt by dx is nothing but T1 minus T2 divided by L. So our aim is to find out the value of T2. So put that values into the equation. So we know that value of Q is equal to 5000 is equal to K is nothing but 0.2 into area is nothing but 20. Then T1 minus T2. So we have to take directly as a T1 minus T2. T1 minus T2 divided by thickness, that is 0.025. Okay. Suppose in this case K is given, thermal conductivity is given 0.2 watt per meter Kelvin, and temperature is given in the degree Celsius. So if suppose T1 is converted into Kelvin, so what we do, we have to adding the 273 into T1. Similarly, we have to adding the 273 into T2. Okay, so instead of that we have to take directly as a T1 minus T2. So from that we get the value of T1 minus T2. So from this equation, by doing the calculation, we get the value of T1 minus T2, that is equal to 31.25. Okay, 31.25. So from that, what is the value of T2? So T2 is equal to T1 minus 31.25. So what is the value of T1? That is nothing but 415 minus 31.25. So from that we get the value of T1. So T1 is equal to 383.75 degrees Celsius. Okay. So this is the answer in the degree Celsius. Now we have to convert it into Kelvin. Then we get that answer is, what is that answer? 656.75 Kelvin. Okay. So write down this. Those who are remaining, write down this. Okay, so this is the problem number 3. Okay, fourth and fifth problem is same as a first three problems. Now we have to go for the directly as a problem number 6. Okay, so write down this problem number 6. Write down. This is a common data question. Write down. Next problem. A wall 300 thick. A wall 300 thick is made up of two layers. A wall 300 thick is made up of two layers, two layers, two layers A and B, two layers A and B. To stop, the temperature is shown in sketch. The temperature is shown in sketch. The temperature is shown in sketch. Temperature is shown in sketch. To stop, the ratio of thermal conductivity of two layers is the ratio of thermal conductivity of two layers is the ratio of thermal conductivity of two layers is the ratio of thermal conductivity of two layers is Ka by Kb is equal to 2. Ka by Kb is equal to 2. Ka by Kb is equal to 2. And draw this diagram. Two sections are given, A and B section. So at the A section, left hand surface temperature is given T1 is equal to 1325 degrees Celsius. 1325 degrees Celsius. Then in between two surfaces, in between A and B, that dotted point is given as a, at the bottom side T2 is equal to 1200 degrees Celsius. 1200 degrees Celsius. And at the right hand side of surface B, T3 is given 25 degrees Celsius. 25 degrees Celsius. 25 degrees Celsius. Okay. Once again, I have reading the question. A wall 300 thick is made up of two layers A and B. The temperature is shown in this sketch. The ratio of thermal conductivity of two layers is given. Ka by Kb is equal to 2. Means thermal conductivity of A section is double of the thermal conductivity of section B. So from this we have to find out the, write down. First find the ratio of, first diagram is over. Anyone reply me? Only temperatures are given. T1 is given 1325 degrees Celsius. Then T2 is given in between A and B section, that is 1200 degrees Celsius, and T3 is given 25 degrees Celsius. Okay. Then first find the ratio of thickness of two layers. Find the ratio of thickness of two layers. Thickness of two layers. म्हणजे आपल्याला रेशो फाइंड करायचा आहे, कशाचा रेशो फाइंड आउट करायचा आहे? वी हॅव टू फाइंड आउट द रेशो ऑफ थिकनेस ऑफ टू लेयर्स. मीन्स वी हॅव टू कॅल्क्युलेट द थिकनेस ऑफ सेक्शन A and thickness of section B and find out the ratio of these two layers. And second, what is the thickness of layer A? First we have to find out the ratio, and in second case we have to find out the what is the thickness of layer A. What is the thickness of layer A? तर पहिल्या केस मध्ये आपल्याला काय फाइंड आउट करायचं आहे? ए आणि बी चा जो काही थिकनेस असणार आहे त्याचा रेशो फाइंड आउट करायचा आहे. आणि इन द सेकंड केस वी हॅव टू फाइंड आउट द थिकनेस ऑफ द सेक्शन और लेयर ए. So how to find out this? Anyone? What is the mechanism to find out these values? Okay. So first of all, we have to write down the equation for the heat transfer through the section A. A section मधून heat काय transfer होते ते आपल्याला माहित आहे. What is the equation to find out the heat transfer through that particular section A? That is Fourier's law of heat conduction. So we have to write down the equation for the section A, that is heat transfer through section A means QA. Notation is QA is equal to K into A into T1 minus T2 divided by LA, thickness of section A, and K is nothing but K into suffix A, thermal conductivity of section A. And similarly we have to write down the equation for the section B, that is QB is equal to KB into A into T2 minus T3. For the section 2, what is the temperature difference? T2 minus T3. And for the section A, what is the temperature difference? T1 minus T2. So in that way we have to change the notation for that particular section. So what is the equation for the QB? QB is equal to KB into A into T2 minus T3 divided by LB. So whatever the heat flow which is takes place through the section 1, that amount of heat now transferring into the section 2. म्हणजे सेक्शन ए मधून जेवढी हीट ट्रान्सफर होणार आहे तीच हीट कुठे जाणार आहे? सेक्शन बी मध्ये जाणार आहे. So from that we have to equating the equation number 1 and 2, that is QA is equal to QB. So from that equation QA is equal to equating QA is equal to QB, we get the value of LA by LB. Okay, so find out the value of LA by LB. समजलं का बघा? सेक्शन ए साठी किंवा लेयर ए साठी पहिला इक्वेशन लिहा फोरियर्स लॉ, that is QA is equal to K into A into T1 minus T2 divided by LA. Similarly, we have to write down the equation for the layer B, that is QB is equal to KB into A into T2 minus T3 divided by LB. जी काही हीट फ्लो होणार आहे ती सेम असणार आहे. So because of that QA is equal to QB means we have to equate that both equations, and by equating these two equations we get the value of LA by LB. So tell me the answer of LA by LB. What is the answer of LA by LB? Put that answer in the chat box. Understood or not? We have to write down the Fourier's law for the layer A, and then we have to write down the Fourier's law for the layer B, and heat transfer from the layer A and layer B is same. So we have to equate the equation of QA and QB. So by the equating the equations of the QA and QB, we get the value of LA by LB, that is thickness of the layers, thickness ratio of the thickness of the two layers, ratio of thickness of two layers. So can anyone tell me the answer? Anyone? समजले का बघा? लेयर ए साठी फोरियर्स लॉ लिहा, लेयर बी साठी फोरियर्स लॉ लिहा, ते दोन्ही इक्वेट करा, तुम्हाला काय मिळेल? LA by LB मिळेल. बाकीचे व्हॅल्यू तुम्हाला दिलेले आहेत. सो फ्रॉम दॅट हा एरिया जो असणार आहे, आपण पहिले लेयर ए साठी लेयर बी साठी तो एरिया सेम असणार आहे, कारण एरिया विच इज नॉर्मल टू द डायरेक्शन ऑफ हीट फ्लो, त्या दोन्हीसाठी सेमच एरिया असणार आहे. त्यामुळे एरिया एरिया पण कॅन्सल होणार आहे, लक्षात ठेवा. QA QB सेम आहे, त्याच्यानंतर एरिया सेम असणार आहे. ओके, अँड आवर एम इज टू फाइंड आउट दी LA by LB, आणि KA by KB चा तुम्हाला रेशो दिलेला आहे 2. So from that find out the value of, okay, Rhythm got the correct answer 0.213. Okay, what about others? Rhythm, then we have to find out the value of thickness of layer A. आता we know that value of LA by LB is equal to 0.213. So by using that equation we have to find out the value of LA. Okay, so write down, this is the solution for this. QA is equal to K into A into T1 minus T2 by LA. Similarly, QB is equal to KB into A into T2 minus T3 by LB. Heat flowing is same, so QA is equal to QB. Equate that both equations. So from that, we get the value of LA by LB. Okay. LA by LB किती येते बघा 0.213. Layer A साठी equation लिहायचं आहे, then write down the equation for the layer B. Heat flowing is same, so therefore QA is equal to QB. Equate that both equations. So from that we get the value of LA by LB, that is equal to 0.213. 0.213. And next we have to find out the value of only LA. How to find out the value of LA? So LA by LB we have find out, get the answer, that is 0.213. Then from that LB is equal to what? 4.7 into LA. So LA plus LB is given 0.3 meter, because total wall thickness is given 300 mm. So from that LA plus LB is equal to 0.3 meter. And from this equation we get that LB is equal to 4.7 LA. Put that value into the equation and find out the value of LA. त्याच्यावरून तुम्हाला LA ची व्हॅल्यू मिळते, LA is equal to 0.0526 किंवा 52.6 mm. Okay, so write down this, put your roll numbers in the chat box. Put only once, don't put again and again.